Yeah. So as said, so today we are kind of moving forward to use Python tools for doing data analysis, and that's basically what I do uh, most of my time when doing programming. So I use these kind of data analysis frameworks to actually deal with data and do my research. And I guess it's the same with Dave. So well, more or less, at least sometimes. Uh, Now we are on the wrong overview. This is the overview. So what we are going to introduce you is this kind of Python data analysis library called Pandas, which is named nicely. Uh, so what this is basically that it's somehow and somewhat similar to if you know R for doing statistical stuff. So this is kind of Python version of that program. Of course, it has been developed in a bit different ways, and you can do stuff in a different manner. But basically, the idea is the same, that you have these kind of data frames that you are working on. So it kind of reminds of Excel table. You have columns and then you have rows, and you can interact with those. So Pandas makes this really easy in Python. So Pandas basically provides these kind of easy to use data structures for you. Uh, what is kind of neat in Pandas is that it's kind of this higher abstraction level tool to use. So actually, what is behind Pandas? So the data structures are actually on top of this another Python module called NumPy. On Dave's course, they will use this NumPy module more on the next period. In all the GIS course, we will use some functionalities from that, but mainly we are using Pandas to do all the GIS stuff, and actually GeoPandas, which is built on top of Pandas, kind of extension for it. But just that you understand that there are actually things happening behind Pandas, and they are actually developed in other under other modules. So NumPy is one that kind of brings the functionalities of those data columns and what you can do with those. But in addition to that, there are much more. There is this matplotlib that will be the lesson 7 in this period, when we are actually seeing how you can plot and do visualizations using Python. So this matplotlib is also quite many functionalities from there are actually kind of integrated into Pandas, so you can just really easily do simple plots using Pandas. Then there are SciPy, which is another package in Python that is basically used for doing mathematics, science, and engineering. So there are all sorts of different algorithms included and so on that you can use. So also those are kind of readily available from Pandas. So just to understand that there is actually quite a lot of happening inside this module. What is really neat and really useful feature in Pandas is that it supports a lot of different data file formats. So you can read data from, well, CSV file is the typical data format that you read data in, but you can also read it from Excel files, write it to Excel files, read data from databases such as MySQL, PostgreSQL, and so on. So it's really kind of handy tool to actually take data from anywhere and start doing things with it. So that's kind of cool thing with Pandas, and they work quite nicely. So that's kind of 3 kind of things that are really good about Pandas. Do you have any questions about the kind of basic idea of the, I guess this should be more or less clear. So basically we could actually see and what we can do. So they will now show you some basic stuff. Yeah, okay, so regarding pandas just in general, I am not so far from where you are as pandas users in that until maybe middle of last week, I had never used pandas once in my life previously. But maybe that's a testament to the fact that it's not that difficult to learn, and in fact, it's designed in a way I think that is sort of intuitive, especially if you're used to looking at things like in Excel spreadsheets, like was just mentioned. So yeah, for this part of the lesson, we are going to start by reading in a data file, and so what you'll need to do if you're following along is get yourself a copy of that data file. And so at the top of this part of the lesson here about exploring data using pandas, there's this link to our weather data file. Well, maybe while we're trying to sort out this minor technical difficulty, I can tell you what's in the data file and what it's supposed to be. So the data file is just daily temperature observations from the Kumpula weather station here on the campus from June of 2016. And it's just average temperature, maximum temperature for the day, and minimum temperature for the day in degrees Fahrenheit. And since it's daily values, we expect to see about 30 numbers in that list for the month of June. And we do include a link here to where the data was sourced. So if you want, you can go and download some other data files as you like. In this case, we've taken it from the National Oceanographic and Atmospheric Administration has a climate database. The reason we've taken it from there is, unfortunately, the FMI data is a bit hard to access. It's freely available, but the interface to the data is not so nice. So for now, at least, we're using the NOAA website. Maybe because this may take us a moment to sort out, what I would suggest is if you don't have Spider open, you can go ahead and open Spider. We're teaching you the kind of way to read data files into Pandas directly. But last year we taught the kind of standard Python way of reading files. It's a little bit more complicated. But in that lesson, if you click the link here above where it says downloading the data and preparing, it will take you there to the old way in which we taught people how to read files. And as part of that lesson, one of the first things you do is you print out the contents of the entire data file. So if you go to that page, you can select everything that's here, copy it, and paste it into Spider. Because it might take us, I don't know if we're going to get the data file link working in the time that we're sitting here. So so let's do it this way, okay? If you're at the lesson page for exploring data using pandas, the link in the first paragraph there will take you to the previous year's materials for reading a data file. If you scroll down here to the section beneath point number 2 at the top, there's a place where you see a print data. You want to select everything that is output after that, and then just do copy, and then paste it into a new file in Spider. So I've just copied this, and I'm now going to go to Spider. I'm going to click up here to create a new file. I'm going to get rid of the stuff that's here because we're not creating a Python file. We're going to create a text file. And I'm just pasting in the data that was there.
Maybe, Pendricky, do you want to see if people are able to do this copy and paste solution?
Yeah, I think now I should have the things ready. I just check so that you don't.
Okay. So yeah, this will at least allow us to proceed for the moment.
Yeah.
If we can't get the data file link working properly.
Now it works.
Okay, now it works.
I'll just do it.
Okay. So anyway, for those of you who've attempted this, have you been able to copy and find this thing, copy and paste, right? So then when you go to save it, you'll go to File, Save As, and you can put this any place. I'm going to put it in my home directory just here. The name of the data file should be Kumpula June 2016-W metadata.txt. So this is our observations from Kumpula in June of 2016, including metadata. So that's the stuff up here at the top that describes the source of the data and how it's been processed and things like that. Once you type in the file name, you want to make sure that you select down here that it should be a text file so that it doesn't try to call it txt.py or something silly like that. And so if you select text files from the drop-down list there at the bottom of the Save File dialog box, you can then click Save, and you should have a copy of the data file.
Well, you're doing it, so now the link works. So
yeah, okay.
It takes you to the GitHub page where you should download it with download button, but it's easier.
Yeah. So is there anyone who has not been able to do this that would like to get a copy of the data file? Because Henrik, you can sort of go around and help if you're struggling. I'm just going to click Save, and now I have a copy of the data file in my my home directory. And at this point, I think we are ready to start the lesson. So you should have Spider open. The one last thing that you need to do is up here at the top, you can see this little place where it lists some kind of file path or directory path. If you click the little browse to a working directory thing here, you just want to make sure that the directory you're in right now is the one where you just saved this data file. So if you saved it someplace other than your home directory, then you should navigate to wherever that location is, and then click the Open button. After you do that, it's also good to just click up here somewhere where the directory is listed and press Enter. What that will do is it will make the IPython console work in the same directory where you've just told it to go. If you don't hit Enter, what it does is it allows you to browse some directory, but it doesn't set your working directory in IPython console to be this new location. So, yeah, we should be all set to go. Is there any issues with the data file?
Yeah, so now you should be able to download it with the link.
Yeah, so there's a link at the very top of the lesson. You can go that way if you want, if you haven't copied and pasted it. At this point, unless I see any clear indications that you're stuck, we're going to move on to the actual lesson part. And the first thing we need to do to work with Pandas is it is a module. We need to import it. So I guess you can see down here. Maybe I'll clear out what's there and do import Pandas. And we're going to call it PD. So this is just a shortened name. Yeah, over here on this side. Yeah, we'll get rid of that stuff. So yeah, we're going to import pandas as PD. Like many of these Python modules, there are kind of typical shortened versions of the names. When you see someone import NumPy in a script, it's almost always imported as NP. Pandas seems to be almost always imported as PD, and that just makes it shorter when you type in things. Now what we're going to do is read in our data file, and we'll do that by defining a variable where we're going to store the contents of that file, and we'll call this data frame. We'll come back to what a data frame is in a moment, but it's a pandas term. And you're going to do pd.read_csv. And then we're going to give the name of the data file that we want to read. And if you start typing in Kumpula and hit tab, if you don't have anything else in that directory that starts with capital K, U, M, P, the IPython console will automatically complete the rest of the file name. So if you don't want to have to type in that whole long file name, that's a useful little tip. It also will indicate to you whether or not you're working in the same directory as the data file. If you can't hit tab to get the rest of the file name to be filled in, let Henka know, and we can give you some help, because it means most likely that you're not working in the same directory as that file. So after that, you can just add the quotation mark at the end and the closed parentheses. And so you'll have data frame equals pd.read_csv, and then basically just the file name as a string of characters there. And at that point, you can hit enter. You won't see any output. But what we want to do now is we've basically put the contents of this file into our variable called data frame, and we can print that out to the screen. So we're just going to print out the contents of data frame to kind of see what happened when we read this data file in. And if you hit enter, you'll see a bunch of stuff that is written to the screen, a bunch of numbers here. You can scroll up if you like, because this is only some of the data that was read in. So you can see some things that, as you might notice from when you copied and pasted, here's some of the text that was at the start of this data file. And there are some other things in here that we didn't have in the data file, like these NaNs. This in Python, NaN stands for not a number. So that is maybe an indication that we have an issue here with the data that we've read in, because there are a number of these NaN characters. If you look and scroll through, you'll see a bunch of them on the first 7 or 6 lines of the file, in addition to the numbers that appear to have been read in properly. So we've got these NaNs, and the other thing that seems a little bit suspicious, we have 30 days of data, but we have an index here. So this, if you look here in the far leftmost column, this is basically the number of the row, the index. There's 36 of these. So if we want to interact with 30 days of data, we have 36 lines of stuff we've read in and assigned to a variable, we have an issue. In the way the lesson was set up online, you were not yet to have meant to see the top of this data file, but since most of you copied and pasted it, you probably already know what the issue is, and that is that we have a file header here. We have stuff at the top of the file that's not the data we want to interact with. This is useful information, but it's not what we want to analyze here. And so what we want to do is basically tell Pandas, when we read in this data file, we want to start down here where the data starts. So skip this stuff at the top. If you go back to your IPython console and you just press up to where we read the file in the first time, we can just add one thing here. So after the file name, you can put comma and then skip rows equals 8. All this does is say, when you start reading this data file, don't read the first 8 rows of it. Start at row 9, or at the 9th line of the file. And by doing that, making that simple change, if you just then go to the end of the line and hit enter. Now if you print out the contents of data frame, you should see something that looks a little bit nicer, and that is here just numerical values under some headings. So we have temp, max, min, these kind of things. Over here on the left side we have the numbered rows, and you can see that we have 30 rows of data. The index value of course starts at 0, so this goes up to 29 for the maximum value for the index. So that's 30 days worth of data. In case you're wondering, you can probably already see that this first column here is the year, month, and day of the observations. Okay, so that's good. We've got our data read in. You can see that we have these different headings up here at the top that are indicating which data is in which columns. This almost looks a bit like an Excel style of spreadsheet at this point in terms of how things are labeled. Now, there is a note on the exercise online. Here we went in Spider and looked at the top of this data file by loading the whole file in and seeing, what do we have to skip over to start reading in our data. If you're dealing with really big data files, there are other ways to do this, and you can check the lesson online to see how to do that. So we can explore a little bit now what we have read in this data file, and this is just going to kind of show you a few useful functions in Pandas to give you information about data that you have loaded into what is called the Pandas data frame. So we could start by doing something like this, printing data frame dot columns. So this is going to tell us something about the different columns of values we have in our data file. If I print dataframe.columns and hit enter, I see that I get back year moda, so that's year, month, day. That's the first column, temp, max, and min. These are just the headings that we saw at the top of the data file when we read it in. If you're loading in data files that you haven't necessarily looked through in detail in advance, or you want to make sure that you've read in your data in the right way, this is a nice thing to see that the labels for each of the columns actually correspond to what you expect. There's some additional stuff here. This D type is just telling you what kind of data this information is here, and it says it's a type object. In Pandas, that's just meant to indicate that this is text information, not something numerical. And you can see obviously that these are text names, not numbers. Another thing you might commonly like to do is take a look at what the index range is, or the index values are for your data set. So kind of how many rows. We've seen the column names. You can do that by printing out data frame dot index. So again, we're just typing in the name of the variable, and dot index is an attribute of the data that is known by Pandas. So when you get this printed out, you come back with something called a range index that starts at 0, stops at 30, and has increments of 1. If you look along the left side here, we see something that starts at 0, is separated by an increment of 1, and does not end at 30, but ends at 29. So this is just like the range function in defining ranges of values in a for loop. This last value that's listed as the stop is not included in the range itself. So that might look familiar if you were thinking, I do range of 5, I get 0, 1, 2, 3, 4. The 5 is not included in that list. So this is just giving us a little bit of information about our data. If you just want to know how many rows of data do I have in general, the easy thing to do is just to print out len of data frame dot index. So in that case, we just say, what is the length of the range of index values that we have, and you get back what we expect here, that is 30. We know we have 30 days in June, we have 30 rows of, or 30 lines of data in our data file, and so this is not necessarily a big surprise. So now we have time for a little question, and I will pull up the question maybe here so that you can see it on the screen. Yeah, there we are. And I'll make that about as big as I can. So based on what we have seen up to this point, we haven't seen very much in Pandas yet, but based on what we have, what output would you expect to see if we did the following? And that is data frame equals pd.read_csv, cumpula blah 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 blah, and skip rows equals 9, and then printed out data frame.columns. So just think about what we were just looking at, and I will turn the poll question on here. In just a second. Maybe I'll do it here since I have this open. Turn that off. Turn this on. So on the polling page, there should be a question up. You have choices that look like this. So what output would the lines of code produce? And you get to choose then from these options what that code would produce. Maybe I can try to get one of these screens. Data file.
Change the working directory.
Okay. 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 So yeah, the questions up here on the right side, you can put in your answers over there on the left side for what you think you would expect to see. And I've just been informed that there's a bit of trouble with the loading in the data file and finding the working directory in Spider in Windows. I guess maybe the best thing for the moment is just to kind of sit tight while we go through this part of the lesson, and at the break we can try and see if we can solve some of those problems. I've only tested it on a Mac, so sorry. But yeah, we've got some responses here. You know, this is a question, again, that's kind of a thought question, so you don't necessarily need to have Spider open in front of you to answer the question. So maybe we'll get a few more responses and then we can discuss the responses and the expected output. Okay, so 13, okay, all right. 13 is not a lucky number, so we'll, now that we have 14, we'll arbitrarily decide we can move on. So yeah, the vast majority of you here have selected this option for index equals 2016 0601 blah blah blah, and that's right. If you tell the Pandas to skip the first 9 rows of the data file, I'll open it up here over in Spider, it's going to start reading data from right here. And the way that Pandas operates is it's going to assume that the very first row that's read in by default, if you don't give it some other labels for what the column should be referred to, it assumes the top row is the names of the different columns. And so in this case, it would just assign a value from the data to be the column names here. So as you can see in the responses, I think most of you picked up on that. And the point is that you should just be aware that it's worthwhile to do things like check the contents of dataframe.columns to make sure that you actually have not lost any of your data or given some name that you don't expect to the columns there. So yeah. Any questions about that? All right. So we've seen that we can get our names of our columns, we can get some information about the rows and how they're indexed. If you just want to know how big is my data set just in general, you can also find that using print data frame dot shape. And all this is going to do when you hit enter here is show you the number of rows of data that you have, comma, the number of columns you have. And so again, all of these things here are what we can call attributes of this Pandas data frame data type. These are things that are known about the data when you define it in Pandas. So I've mentioned, we've given this variable name called data frame. We've mentioned this name of a data frame already, and maybe you're wondering, what type of data do we have here? If you use the type function, just like we have earlier to check data types in Python, you can do type and then data frame, and sure enough, it comes back saying that this is something that's part of Pandas called a data frame. Now, all that means is that this is a way in which Pandas organizes its data. We've seen Python lists, and you know that Python lists have the square brackets and values that are separated by commas. Here, in a Pandas data frame, we have an explicit labeling of the different index values that are along the left side, just like the rows you would have in Excel. And then there are names of the columns up at the top. Again, very similar to Excel or most spreadsheet-based programs. So this tells us the type of data for data frame itself. It doesn't tell us anything about what's in the data frame, what's stored in here. And that's often, you don't care about the fact that this is a data frame. You want to know what the values are that are stored inside there. And so there is a function for that as well, an attribute rather. So if we print out data frame dot dtypes, so again, dtype is used to indicate a data type in Pandas. Dtypes will give you, if you hit enter, the data types of all of the different columns in Pandas. So it tells us, for instance, here that year moda is an int, and in this case that it's using 64-bit precision to store that, so it's just a high precision number, so you could put quite large integer value there for that variable. And then the others are floating point or decimal values, again with 64-bit precision. So I don't think there's any kind of big surprises there, but these are just kind of useful things to be able to see in Pandas. Now we've seen that you can print out data frame, and get your entire data set. If I just do print data frame, and I did that quickly, I know I typed quickly, but we've seen this before. You don't need to necessarily do this. But we have these columns here, and maybe you don't necessarily want to see all of this data, but just a single column. The way to do that in Pandas would be to print out data frame, and then a square bracket, and the name of one of those columns in quotation marks. And don't forget your close parentheses. So before, when we used the index values to find things in the list, we just put them in the square brackets with some number. And in Pandas, if you want to get the values from a certain column, you put it in square brackets in a similar way, but you list here the name of the column, not just some numerical value. And if you do that and hit enter, what you see is the list of temperatures we have for all of the days of June in 2016. And down at the bottom, it tells you the name of the variable is temp. Well, we kind of knew that. But also the data type is float64. When you read in a new data file, this can sometimes be a useful thing to do, to print out some of the things like dtypes or just an individual column to make sure that the data was read in with the format you expect. if you have things like missing data values in the data file, there are lots of different ways in which different people fill in a missing value. Sometimes they put in some star characters, or sometimes they just leave it blank, or they put in some NA or something like that. When Pandas reads in the file and it finds some text in there, it might not read it as a numerical value, but instead read it as a text value. So we'll see maybe an example of that in the exercise.
Yeah, in the exercise we will see an example when we're working with real data. So you have these kind of no data values in there, and you need to deal with them. Also, on the second half of this lesson, we will see how you can actually drop those values and how to fill them.
Yeah. So we'll do a couple more things here in our basic kind of exploring our data in Pandas, and then we'll take a break and move on to doing a little bit more of kind of data analysis type stuff in Pandas, or processing data, I guess is probably the better way to say it. But yeah, so we just did this print of dataframe.temp, and what's interesting is if you go here and instead of typing print, type in type, just to see, you know, what happens if we take a single column out of our data frame. What data type does it have? Oops. So that's just type, and then same thing we had before. I just pressed up and then deleted the print and replaced that with type. And what you see here is that it doesn't come back saying it's a Pandas data frame, but rather a Pandas data series. So if we take a single column out of a data frame, it's called a series in Pandas. On the website, they show you an example of how to take a Python list and convert it to a series in Pandas. I'm not going to do that right now. It's quite straightforward, and you can read how to do that on the web page. But the interesting thing about the data series is that it has a set of functions that can be used to analyze the data that's stored in the series. So for instance here, if we do data frame, and we look again just at temp, there are functions that you can apply to this data frame like mean. So here I'm typing data frame temp and then dot mean. So this is like a method that's built in for analyzing a Pandas series. And you can probably already guess what this is going to do when you press enter. And that is return the average value, or the mean, of all of the temperatures in that data series. If you press up and you feel like playing around with this, you could also do min. That works. You can do max. There's lots of different options, and they're all listed, or not all of them, but at least a common selection of them are listed on the lesson on the web page. There's also STD for standard deviation. If you want to know how much temperature varies from the mean value on average in the month of June in 2016 in Kumpula, very useful thing to know. You can see it, on average it's about a 5-degree difference from the mean in a given day. So there's those kind of things, those built-in methods that are quite handy, and in fact in the Intro to Quantitative Geology part of the course we'll deal with some of those things later on in the course in NumPy, not in Pandas most likely, but it operates exactly the same way. This is nice because it allows us to get, you know, some information about our data quickly. It's very efficient. These functions are very fast. But oftentimes you want to get more than one value at the same time. And there is a function built into Pandas to handle this. So if we do dataframe.describe, describe will tell us information about our data. It gives us actually quite a bit of, yes. That was meant to be helpful. Yeah, it's left up too. So dataframe.describe will give us a bunch of information all at once. All right, so here we're back. What it does is it gives you each one of the columns of your data set, and it gives you the count. So this is the number of values in each of the columns, the mean, standard deviation, min, max, and even these quartiles. So like, the 50% of the values are below this cutoff value, 75% of the values are below this cutoff, etc. Obviously, if you're dealing with sort of statistics, these are common things to do, and it's not a big surprise then that this is built into Pandas. So the last thing I'll show you before we take a break here is just a way to do data type conversions. So there would be cases maybe where you want to just deal with integer values instead of decimal values, or vice versa, or convert your numbers to text to be able to quickly print them out to the screen in a series of print commands or something like that. What you can do in that case is you could take something like data frame, and we'll again look at temp. And we know that right now data frame temp is a series of floating point values, but we can use this method called asType, and in here we could do, we'll do first, I guess, str. So this is going to take our values in dataframe.temp and just convert them to be represented as strings, character string values. If you do that and hit enter, you don't actually see anything that looks visibly different from what you saw before, but you do see that the data type down here at the bottom is this type object, which again is just indicating that these are the character strings rather than numerical values. So that's kind of what we expect. The more obvious one is if you do the conversion to an integer. So I just pushed up here and just replaced string with int. Obviously what happens here is that we just lose everything to the right of the decimal point. And we make a note of this in the lesson online. This is just straight truncation of the data. It just chops off the decimal point and loses it. It does not round anything. And if you want to round the values first and then convert them to integers, you have to do that in that order. Otherwise, things like 65.8, which is the second value in the list, just gets truncated to be 65. Just drops the decimal point. You can see online you can do the rounding first if you want to do that. To avoid confusion, I'm not going to show you that at the moment, but if you're curious, we have it on the lesson on the webpage. So with that, I think it's certainly about time for a little break. So why don't we take 10 minutes and then we'll come back and continue with some processing data in Pandas.